let's find out the common date. It looks like starting from June of 2003. So let me get these dates into a new sheet. I don't want the first one. SPY, FA, and EM. I'll just 2003. Just values and formats. Let's do the same thing for FA. And finally, EM. I'm going to calculate a few things, the average and standard deviation during this period, average of the returns. So during the last essentially 20 years, S&P 500 yielded about 85 basis points per month. I'm going to multiply this by 12 to kind of get a roughly annualized idea. The markets for developed foreign countries about 737 and emerging 932. You're probably thinking, why are we even having them in there? Let's look at the risk using standard deviation. I'm going to make that into percent. Turns out that the others are also riskier, but let's look at the correlations. Correlations between SPY, FA, Excel has a function called Correl. Two arguments. The first is SPY returns. Second argument is FR returns. For EM, let me calculate all of them first. Okay. As you can see, they're not perfectly correlated. There's a high degree of correlation between American markets and other developed markets, but the degree of correlation goes down. Similarly, correlation between foreign developed markets and foreign emerging markets, it's also less than perfect. Whenever correlations are less than perfect, there is a chance to improve upon what you want to call diversification. Just as a handle. For example, let's do the following. Let's find out a set of weights a portfolio that has everything in SPY will have these weights, one on SPA and zeros on the others. I'm going to ask Excel to find the set of weights that has the mean return that is the same as SPY, but minimum risk. You can do that using the solver under data tab. If you don't have this on your computer, that solver, go to file menu, options, add-ins, down here, manage Excel add-ins, go. Make sure that the solver is checked. For your own computer, you have to do this only once. If you have done it before, it's there. For these computers, you have to do it every time. I'm not that much interested in this class, just to give you an idea. Data, solver, okay. I want my objective, let's do a portfolio. Let's calculate the portfolio return. Which is sum product of the weights, the returns, hence these are mean and standard deviation of the portfolio. And here's what I'm gonna do. I'm gonna actually deduct the return of the S&P 500. All right. So this is return over and above S&P 500. Under data tab, solver, I'm gonna ask Excel, my objective is the risk. I want to minimize that risk by changing the weights of S&P and EFA. The third one is determined automatically, subject to the constraint that excess return is equal to 0. And I'm gonna make sure that unconstrained variables could be any number. Solve. Okay. Now, here's the optimal portfolio. It basically says you need to short, at least based on the last 20 years worth of data, you need to short the emerging markets a little bit and have a little bit of developed markets and put most of it on American markets. If I wanted to make sure that all weights are non-negative. Let me see. I'm going to do the following. These are some of the weights. Shorting emerging markets in general may not be that easy. I'm going to do data, not data analysis, I'm sorry, solver. Again, I want all of that, but I want the unconstrained variables non-negative, but I also want to add a restriction that says sum of the weights is equal to 1. And now solve it. Actually, it turns out there is no feasible solution. So you're going to have to allow some shorting. All right. But in general, foreign stocks, do play a role. One of the reasons why we also want to look at the international equity markets, in addition to diversification, the rules and regulations are not the same as the rules and regulations in the United States. So if you're going to invest into foreign markets, you need to be careful about how you're doing it.